Hello guys, can you hear me? Hope you do. Can you write on the chat from where you're listening to us? It will be easier to see if you can hear me. Okay, you can hear me. You can hear me? Okay, cool, perfect. Yeah, guys, if you can write on the chat if from where you're writing, that would be perfect, because then I would know if you can hear me. Yes, perfect. Big Z. Okay, so today we're gonna have just one lecture with Laurent, because Arash is not available tonight, and Laurent will tell us about building smarter solutions with no expertise in machine learning. So I will just pass you the voice, and you can start. Yeah.
Okay, thank you, Michal. Hello, everyone. I hope you're doing well. Wherever you are, I guess most of you must be in Poland. So I'm Laurent. I'm speaking from Paris, from my home too, I guess, like you. And my goal tonight is to speak about machine learning, but from the point of view of a non-expert. So how, if you are a developer or if you have technical background, how can you do something smart with machine learning, but without any expertise in machine learning? Okay. Right. Okay. So a quick introduction. So I'm based in Paris, so you guess that I'm French, maybe from my accent. My name is Laurent Picard. You can follow me on Twitter at Picard Paris, or anywhere else on Medium, on GitHub, on LinkedIn, and so on. I've been working for Google Cloud for almost 4 years now. And in a previous life before that, I was an ebook pioneer. So that means that I made, for instance, I co-made one of the first ebook reader in 1999. And now at the time, it was a big innovation and it kept me busy for 17 years. So I also co-founded an ebook company. So I guess now the next step for me is to keep focusing on cloud technologies, and that's what I've been doing for 4 years, and I guess it will keep me busy for maybe another 20 years. Okay. I very much love to start with this quotation, this quote from Clark, because even after 4 years of watching machine learning applications, I'm still feeling magic whenever I see something new developed with machine learning. So, but as you know, it's just technology, and my goal tonight is to show you that we can still do it and still feel some magic. Okay. So here is my definition of machine learning, or anyway, that's the way I've seen it for 4 years now. We have data. This is our input. We have data, and from data, we manage to extract information and basically understand what our data is about, what's in our data. Okay, that's not the real definition of machine learning. Machine learning is actually a part of AI, of artificial intelligence. And one breakthrough within machine learning is deep learning. So deep learning is a field that has been very successful for a few years now. And that's what's bringing most innovations in AI right now. Okay. How does deep learn? So yeah, I will mainly talk about machine learning, even though most of the solutions are actually done with deep learning. But machine learning is a very generic word now. So how does deep learning work? 40 years ago, researchers tried to mimic the way our brain works, or anyway, how we think it works. For that, we need many examples. And the magic, and it's still the magic, is that thanks to that, we manage to solve problems. We don't always know exactly how or why or precisely where the solution is coming from, but we manage to solve problems that we couldn't solve before with the algorithms. Why is it working now? It's because we have a legacy of centuries of science, right? In mathematics, physics, chemistry, everything. For, let's say, for 20 years, we've been now able to process data. We can store data on hard drive and SSD now, and we can read and process a lot of data. And for 10 years now, let's say, cloud technologies let us do that quickly, easily, especially in the cloud, or anyway with new technologies provided by cloud. And also the CPU power that we have now is unbelievable. Whether it's on a CPU or on a GPU, we can do something that was really impossible even 2 years ago. Okay. So let's take a step back. Okay. What is the state of the art? What can we do? How can we benefit from machine learning today? So, of course, if you are an expert, and I hope the rest of the talk will be of interest to you anyway, also. So if you are an expert, you know already how to deal with neural networks. Maybe you know how to build them from scratch and everything. But if you're a developer, you can still integrate machine learning. And there are two ways. The first one is to use existing machine learning models. So they are available as APIs. So that's what here at Google we call machine learning APIs. And they are pre-trained models. And those are generally the state-of-the-art model that we have internally at Google and that we make available to you through APIs. But in some cases, that will not be enough because those models are generic models, even though they are very rich. In some cases, you will want to apply to customize a model to your own needs for a business need, for instance. Okay, and that's new techniques that have been developed for a couple of years only. I started talking about AutoML at Google only 2 years ago. And this is also a new, very successful field. And my goal tonight in this talk is to show you as many examples as possible of the APIs, of what you can do with APIs, and to give you a glimpse of what you can do with AutoML. Okay. Internally, we call that the building blocks. So those are the basic bricks, like Lego bricks, that you can take, assemble, or integrate into your solution to make it smarter. Okay. So let's start with the APIs, the machine learning APIs, those models that are ready to use. They have been pre-trained sometimes on millions of samples. If you remember my definition, you start with data. And this data can be almost anything, can be text, can be visual, images, videos, or can be also speech. And you extract information from that. And sometimes the information that you want is actually your input that has been transcribed into something else. Okay. So let's start with the Vision API. So this is purely for personal reasons, because when I was a student in the 90s, I was trying to understand what was with my teachers. We were trying to understand what was in pictures to automatically detect something in pictures. And at the time, the way we had was to do edge detection. So imaging, filtering to try to detect object edges. It kind of worked, but it was very limited. And as soon as we would try on new pictures, it would just fail miserably. So that was really frustrating, and machine learning has solved this problem. So if you use the vision model, how does it work? So you provide a picture. So first, the vision model is able to describe you the picture with labels. So here in this picture is about nature, flowers, a garden, plants, botany. So everything is correct. Most of the time you have a score that is a level of confidence between 0 and 1. So here about nature at 95%, that's good. Here on the right, this is the JSON stream, the JSON response that you get if you call the API directly from a web page, for instance. Okay. Next, it can be more precise. It can tell you where it thinks this picture has been taken by doing some matching with existing pictures on the web. Of course, by default, it's not using the GPS location that could be found in the picture. And so here, this picture is from Hobbiton, where the Lord of the Rings movies were shot. And it tells me, it gives me the GPS location where it thinks this picture actually was taken, and that is correct. Even though this picture does not exist. I mean, I took it on the web, but I changed it. I flipped it, I zoomed in and cropped it. I applied a filter, a color filter, so there's nothing in common with the original picture. It's not. It, of course, it looks like it because it's derived from it, but it has been able to match it. More precisely, a vision model, the Vision API, is able to give you the location of some detected objects with the bounding boxes. So here we have the cast of the Lord of the Rings, probably in a restaurant. And what we get are classes, so persons, here, 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 even a person in the back, even clothes, so like the pants or the tops. And back in the list, I even have this ceiling lamp that is detected. Okay, so it's been working now for a few years. It's very efficient. You can know the exact location of objects. Even more precisely, you can know whether there are faces in the picture, and with their exact location, as well as the different features like the eyes, the nose, the mouth, and everything. More than that, can try to detect emotions. So here in this example, and by the way, that's not a real human, that's a 3D rendition, similar to a human. The Vision API tells me that this face is likely angry, and that's correct. Gollum is always angry. I have the position of the head in 3D and some additional features. Okay, so it can be useful to detect, not recognize, detect faces. And we'll do a demo a little bit later altogether, okay, where you'll be able to take your smartphone and send selfies to me. Okay, we'll try that in a live demo. So next, another problem that has been fully solved thanks to machine learning, OCR, optical character detection, recognition, sorry. So you have text on a picture and you want to really get the text out of the picture, not deal with pixels anymore. Many companies have worked on this problem before for, I think, 30 years now. And they did it by hand. They tried to match and letters and everything. This time, the vision model has solved this nicely. So it's almost perfect. Here, so this is a screenshot, and what I get are the different levels. So I get the different chapters, let's say, the big blocks. I get second level, the different sentences. Another level, I get the different words and the different symbols. And here, this is perfect, you see. So it's also interesting to see the limits. So I applied a perspective effect to this screenshot, and it still works perfectly. The only difference is that the English quote was detected like this here, while previously it had, previously it had been detected like straight quotes. But everything is perfectly correct. So OCR is a solved problem. It means you can scan documents, you can extract the text out of them. The next level, and this is a lot harder, a problem that is a lot harder, it's handwriting detection. So here, this is a piece of paper written by Tolkien, and the Vision API is able to recognize and detect text on it. So it's a lot harder. So it's not as perfect as with typewritten text. Handwritten text can be so much different, but it's very, very good anyway. It's the only major mistake it's making here is that shadows has been detected with a V. What's cool with machine learning also is that with time, the machine learning models improve over time because they just keep being trained, right? Or new models with different architectures are replacing previous ones. So here it's already very good, but in my experience, and that was not, it was making a couple of mistakes 6 months ago. So with time, it's getting better. So maybe it will not make this mistake a little bit in a few months. I don't know. Okay. So next, it's also able to detect entities in pictures. So entities are persons or objects that are famous. And basically, you know you're famous if you have a Wikipedia page, for instance. That's one way. Or if we talk about you a lot on reference sites. And so this time, again, I took a very rare picture that I had never seen before. It's unique. It has been used only once in a Spanish newspaper. I changed it, I cropped it, zoomed in, and changed the colors. But it's the Vision API is able to match this picture with an existing one and tell me that most probably this picture is about Tolkien, and that is correct again. It's also able to tell me where I might have stolen or derived the picture from. So this is the location of the original picture. Okay. One very cool feature also as a developer is that I can deal with identifiers. Here I have an entity ID that is unique, and that is unique for J.R.R. Tolkien, the father. If there was also Christopher Tolkien, the son, in the picture, maybe I would have J.R.R. Tolkien and Christopher Tolkien with detected, and I would, in this case, I would get two different IDs. So that's pretty cool. You can work use identifiers instead of dealing with strings, and you know strings can be different. Here it's written like that. Here it's J.R.R. Tolkien without the spaces and so on. So I told you it's machine learning API. So they are available either on cloud APIs, or sometimes they are embedded. So for instance, in a browser or in Android, you can sometimes use subsets of these APIs. But what we do, what we've done at Google also is that we have developed client libraries, so wrappers around these APIs. I'm pretty sure you'll find here one of your favorite languages. In my case, I've been focusing on Python for a couple of years now. And so this is the Python code, and the only one that is necessary to do face detection. Well, it's always the same principle. You create a client, you provide the input, so here it's a picture, and you call the feature that you're interested in, so face detection, for instance. And on a picture, on average, let's say about after 1 second, you get the answer. And you can use the results right away here. Okay, so you see a very little number of line codes. You've seen what you can do. So there are other features, but that's mostly what you can do with the Vision API. There are new features coming. You can extrapolate what you can do with videos, because it's almost the same. The difference is that you have an additional dimension, time, right? Pictures are in 2D, videos are in 3D. You have the frames, but also the time. So what it means for videos, especially, is that it means you can detect sequences. It means you can know how you could split the video in different sequences. You can also, for object detection in pictures, here you can detect object, but you can also track them in time, right? You can follow a certain object. If there are several objects of the same time, you can follow them throughout the sequence and not lose track. Okay, and like for pictures, it's able to do OCR in videos, to do also, I didn't say, but to do logo detection, face detection, person detection, and something that is unique maybe to videos, pose estimation. How is the person's skeleton localized in space? Okay, so maybe let's show you a demo, because every time, if you're able to understand what you have in your input, in your data, it means you can understand your data. And it also means you are able to index your data. So for instance, this video has gone through the Video Intelligence API, and here are the labels I get. So for instance, I know, what do I know? That there is a spiral galaxy at the beginning, okay?
With tiny bits.
Here I have a human. So you see, those are the different sequences, and it means you can really index videos and understand where entities are located. Here, there's a polar bear.
You'll fix them.
So you see, very efficient and very easy to use too. Those are, again, the Python lines needed to analyze a video. So you create a client. The feature in this example is I want to track objects. You can specify the segments you want to analyze, the whole video or maybe only parts of the video, and you call annotate video, and that's it. So of course you wait a little bit more than a few seconds. It depends on the length of your video. But then you have the results that you can exploit right away. And so here, this is a tutorial I have written to show you. You can do that in a few minutes. There are different features throughout this code lab. And especially from the code I've done, I've been able then to write an article and show how we can generate animations to track, to show the different objects that you have in a video. I'll give you the link at the end. Yeah, by the way, you don't have to take screenshots or whatever. You will find, I will give you the link to the presentation at the end, okay? So stay tuned. Okay, so next we've seen pictures and videos. Next, text, and that's maybe the first field where experts try to solve problems. That is to understand text. So, and especially there are many different languages around the world. So experts have been trying in their own language first and trying to solve this. Once again, machine learning has solved mainly this problem. And for many different languages, for instance, all Latin languages, of course, with some fine-tuning, can be analyzed. It works for classes of languages. So, of course, Asian languages derived from Chinese or Japanese can be analyzed, thanks Arabic also, of course, and Hebrew. So let's try this example. So if I give this sentence, but it could be a very large piece of text to the natural language API. And I forgot to tell you, of course, this field is called NLP, Natural Language Processing. So the API tells me that this text is in English, okay, and it's able to give me the exact syntax with all the different relationships between the items. And also something that I like very much is that I get the lemmas. So I'm able to work with the canonical form of verbs or nouns. So that's pretty cool. The same sentence, the natural language API is able to give you the entities. So like in pictures, but this time entities are classes. So for instance, persons. Here I have 3 different entities that are detected. In red, persons. Tolkien is a person, a writer is a person, and so on. And here's the type of JSON stream that I get for every entity. Here I have Tolkien, and you'll notice that I have the same identifier here as before in the picture where there was Tolkien. So it means that I can really work when dealing with entities with this identifier. That's pretty cool. British is related to the United Kingdom, and the 3 books at the end are each mapped to works of art, and that's perfectly correct. Pretty cool. Okay. Next, classification. So if you have text and you'd like to sort your text out, you can ask the natural language API for classification. And here what I get is that the main category it should be classified in is books and literature with a very, very high confidence, 97%, and that is perfect. So what could be the use? So for instance, the New York Times is using that to classify old articles that they didn't have on computers, of course, at the time, that they have scanned, and the OCR has been running on it. But once you have the text, then you can analyze it and classify the documents. And I think they have millions of different documents. So it's something that no human could do, or you would have to do it worldwide with a lot of different volunteers, like Wikipedia, for instance. So yeah, classification can be very useful. And if you remember, in pictures, we were able to try to detect emotions. So likewise, in text, you can try to detect sentiments. Are we talking positively or negatively about entities, or globally in a chapter, or in a larger piece of text? So to try that out, I have taken 2 different reviews. The first one is positive and is from the New York Times. The second one is negative from Pauline in a social network for book lovers. And what I get, so I just showed you the different the result at the sentence levels. What I get is a score between -1 and +1. And these sentences do come from Pauline's review, who hated the book. These sentences come from the New York Times review, which was pretty positive. And of course, there are many, many sentences that are neutral, because in majority, we are neutral when we speak about stuff. What's the use of that? So many companies are using that to, for instance, to process customer emails, to understand, or to do statistics, to understand how positive or negative are their users. I know of one company in the UK who's using this to process customer emails, especially negative ones, in priority. So it means they are very efficient to deal with problems, and they know that they can read positive emails a little bit later in the day, but deal with actual problems in priority. So it means they are a lot more efficient thanks to that. Some other companies are browsing the web, can be social networks also. You can browse Twitter, you can browse customer emails, and know how people are talking about your products or your company. And you can do statistics from that. You can analyze in time how well a product is doing. If people are talking more and more positively about your product, sorry, maybe you have solved all your bugs or something like that. Okay. Again, the client library. So here, still in Python, very few lines. A client, you provide a document, and here for sentiment analysis, you call analyze sentiment. And you have the result very quickly that you can use right away. So that is another code lab that I've written that you can use and try. And it just takes a few minutes if you want to try all the different features of this API. Okay. Then still about text, I will go fast on this one, the translation API. I am sure I've never met anyone so far. There are people, but never meet anyone who hasn't used, especially a developer, a Google Translate. So the translation API is actually Google Translate that you can use in your own application. So it works with many, many languages, and we are adding more. It works on text and HTML. And here the magic, and I really felt the magic before working at Google. So that was 4 years ago in 2016. I was using Google Translate mainly to translate Japanese or Chinese text that I cannot understand at all into French or English. And it was working okay. The translation was okay, sometimes good, sometimes okay. But one day, suddenly, the translation was a lot better. It was of very high quality. And I learned since I work at Google what happened. Actually, 4 years ago, the Google Translate team switched from a statistical model to a machine learning model. And that made the big difference. And for 4 years, what's cool also is that the translation API just got better because when you're using Google Translate, you can tell when a translation is not good. You can even provide a better translation. And when it's used by millions of people, you can enrich your dataset, your samples, your input, and you can improve your model with time. And so for 4 years, the model just kept getting better and better. And now it's already 4 years ago, but now it's even better. So it's almost, so it's not yet at the professional level of professional translators, but this is an API that many companies are using to translate right away and automatically a lot of content. For instance, Airbnb is using that to translate virtually everything from any language to any language. Okay, that's thousands of different combinations. Here, you just need 2 lines to use it. I have more comments here. You create a client and you call translate, and you indicate your target language, and that's it. And you have the result with a very high quality. Okay. And there's a tutorial also to use that online, to try that. So we've seen everything visual, everything textual, now speech. And there are 2 APIs, both ways. You have speech and you want to transcribe it into text, and likewise text into speech. So like the translation API, it works with over 100 languages. Now it's over 120 languages. Once again, it's the machine learning, a machine learning model that is solving this problem. I did work with companies who were experts in this field for the last 20 years, and who try to solve this problem with algorithms, with signal analysis, by working on phonemes, half phonemes, and so on. But machine learning, once again, magically is solving that nicely. Also, something that is amazing is that it's able to transcribe in real time. That's a very hard problem. And also, if you remember, machine learning is learning from examples, from samples, real life samples. So the magic here on speech to text is that thanks to that, it means that it's robust to noise. So that there's no filtering done. It's just that it learns on actual samples that have noise. Natively, they have noise. If I'm recording myself here, there will be noise from my keys or from the surrounding environment. And so when a machine learning model is learning something, then magically it becomes robust to noise. And that's exactly what the speech-to-text API is good at. And that's one of the basic elements for an assistant. When you are using a phone or a home assistant, you can talk to it, right? And you don't even think about it now. For a couple of years, you speak to your assistant, and what happens is that a model at Google, that is the speech-to-text API, transcribe, sometimes it's an embedded model, transcribe your speech into text. And then your text is analyzed with the previous model, the natural language model. Okay. So like before for the videos, if you are able to understand what's in your speech, in your audio files, then it means you can index everything. And you can also ask for the precise timestamp, the precise location in the audio stream of every word. So it means you can look for specific words in audio streams. So that is another code lab that I've written. So this time I recorded myself in French. Here I enabled one very cool feature that is making this API a lot useful. You can ask for punctuation, because in the past, the first model was only able to give you the different words, and you had to understand the different sentences. But now it starts to work really nicely. It's able to give you lower and upper cases, commas, and so on. So here in this case, you see just these few lines. I create a client I call recognize with the options that I want. So I want the location of different words. I want the punctuation. And to help the model, I specify that the input is French. I call this, that's it. And then I have the transcript and in many different languages. Okay, and still with the level of confidence. And here it's very high, and the result is excellent. So you can try that out in this code lab. So now the opposite. So once again, if you remember, 20 years ago, I worked on one of the first ebook readers in the world. That was the first one in Europe. And I did work on text-to-speech. I didn't develop it, but what I did is that I integrated a text-to-speech engine so that our users could push a play button and hear the book read aloud. It was a total failure. Technically, it worked, but it was a robot talking to you, right, to read the book aloud. So here on this technology that is called WaveNet at Google, it has been solved by DeepMind. Maybe you know DeepMind because they have beaten the world champion at Go, at the Go, a game that is more complex than chess or that has more combinations. And here they started to work from scratch, and they've been able to generate models of speech models. The magic also is that there are actually two kind of tricks that are very magical. The first one is that it's very human-like. It sounds like real voices. There's nothing robotic in them. Really, if you haven't tried, you can check that out. And the second magic is that in 1 second, you can generate 20 seconds of speech. So that's better than real time. I'll try to, here, there's one original recording for one of the WaveNet voices, and the second one is the automated generation of the same text into speech. So I'll try, I hope you will be able to hear it, and the game is to try to guess which one is the original one.
She earned a doctorate in sociology at Columbia University.
Okay, so it's very hard to tell the difference, and you can type any different sentence, of course. Okay, let me run the first one again.
She earned a doctorate in sociology at Columbia University.
And
she earned a doctorate in sociology at Columbia University.
It's very, very hard to tell the difference. Actually, the second one is the original one. And so here the magic, you can try that by yourself, is that it's maybe the most advanced machine learning model from all the ones that I've shown you tonight. I have to admit it, I'm a bit jealous because I really love the vision API, the vision model, because that's a field that I love. But here I have to admit that it's human-like. You can be fooled. And maybe the best thing is that you can realize that if you talk to your assistant on your phone or anywhere else, you don't think about it. It can understand what you're saying. It can analyze it, find an answer, and answer back to you. So yeah, maybe let's try a demo altogether. Not altogether, but a live demo on my side. So I'm going to go on Google web search, and okay, and I'm going to try to speak in English, but with my thick French accent. Okay, so let's try that. Okay, what is the temperature in Paris? So
it's 8 degrees in Paris right now.
In the live stream. So what it did is that it transcribed in real time every word and even parts of the words I was started to pronounce. And despite my French accent, it has been able to understand it and transcribe it perfectly. And I think also you could hear the answer. It gave me it gave me the temperature. So maybe let's try the opposite. So here I spoke with a French accent. So let's try on, I don't speak Polish, so, but I'm going to speak French with an English accent. French, okay, so that should be good. Okay. Quelle est la température à Varsovie?
Il fait actuellement 1 degré à Varsovie.
So yeah, so you see it worked too. And the way I said it in French, really, you know that it's a foreigner, maybe someone from London speaking French. And it worked every time here. So what does it mean? It's like when the model is robust to noise, here, considering that the accent is noise, actually the text-to-speech engine has really got the essence of speech, right? It's able, so the speech-to-text is able really to understand the essence of speech. And likewise, the opposite now is very natural when it's speaking back to you. So again, you can try to see the limits with different accents and so on. There are many, many languages, and there are more and more with time. But I still feel the magic where I'm still amazed, because it's a very, very, very hard problem. But only machine learning could solve it. Okay, so that is another code lab that I've written. So it's a tutorial. And that's to show you how you can generate this speech in a very few lines. So here I'm calling my Python function. I'm saying, okay, which is the voice that I want? So here that's an English voice with an Australian accent, here with a British accent, here with English with an Indian accent. Of course, there is the American accent. And here you create a client, you call synthesize speech with the different parameters that you want, and then you get the results that you can save as a WAV file or whatever. So and it's very fast. It's almost immediate, because if you remember, in 1 second you can generate 20 seconds of speech. So typically that is what is used in assistants or in chatbots that you can talk to now. So we have seen what you can do with existing machine learning models, with machine learning APIs. But in some cases, that will not work out for you. That will not be enough. You will want to customize models. And AutoML is here for that. So AutoML is the next magic, because it means you can build your own model, and still without any expertise. So let's start with this example. If we give these two pictures to the Vision API that we saw at the beginning, we will get almost the same results, because basically those are clouds in a sky, okay? But if I want to do, for instance, a weather forecasting application, I need to be able to recognize the different shapes for the clouds. Here, a cirrus, here, an altocumulus. And I'm stuck, right? I just know that I have clouds. So here you can use AutoML Vision, and that is a generic principle, AutoML. You can use AutoML to customize what you've seen before. And the way it works, so here you need to work a little bit more. You need to create your own data set, because you are going to generate your own API or your own model for your own private needs. So you need to provide a data set. You need to provide samples for your business use case. Once you have done that, so it can be pictures, text, we'll see examples. Once you've done that, you can launch a training, and everything is fully automated. By experience, I know that you need maybe to iterate a little bit to create the first data set, to notice that you have some issues. Maybe you made some mistakes. So maybe you'll need to iterate 1, 2, 3 times, and then you can launch a longer training, and then you get a state-of-the-art model and your private API. There are 2 ways to use AutoML. So it will depend on the type of features that you're dealing with. But let's say ideally, you can train a cloud model. So the cloud model is the state-of-the-art. It's the largest model, and it will be on par with what you've seen before on the API. So that's the largest model, and it will be available in your cloud project as a cloud API. But you can also decide, for some reasons, maybe to train an edge model. And an edge model is a model, it's smaller, it's a lighter model, so it's a little bit less accurate, but it's a model that you can export. And you can export it different ways. You can export it in a container. You can export it as a TensorFlow Lite or saved model, so if you know TensorFlow. So it means you can export your model and get it to run in a mobile app on Android or on iOS. And more recently, also especially for the AutoML vision, you can export your model as a TensorFlow.js model. So what does it mean? It means that you can embed your model in a web page, and you can do live prediction. Of course, you need to download the model once, but then once the model is in your web page, then it can run offline. So it means that with edge models, you can maybe export models and get them to run in real life where you don't have connectivity. And I have a very specific use case. If you remember, I worked in the ebook industry, so I have manufactured hundreds of thousands, not millions, but hundreds of thousands of ebook readers. It was, of course, abroad, and we needed to have information. And at the time, we didn't have this technology, but now you can build models to analyze something on a production line and understand it. And very often, the production lines are not connected because the Wi-Fi is not allowed in the factory or for some other reasons. And so having the ability to run an offline model, a model offline, is just great. Okay. So let's go on with the cloud examples. You create the data set. So here you need to work a little bit more. You need to provide, it starts to work with 10 samples of each. So here the problem is image classification. I want to be able to detect pictures according to the cloud shapes. So that's an image classification problem. So ideally, of course, we'd like you to provide 1,000 pictures, but with 10 pictures, it starts to work. And with 100 pictures per label, you start to get very good results. So then it depends on the level of quality that you want to achieve. Okay. But here, in this data set, you see just had about 200 pictures per label. Once you have that, you launch a training. So what I did is that I launched a 1-hour training here. So a quick one to get a rough idea. What happened is that I got mixed results. Okay, above 80%, but mixed. I actually noticed, thanks to that I had mistakes in my data set. And especially I had confused some labels, some clouds for others. So I fixed that. So the data set was better. And then I launched a training that was longer. And of course, the quality was a lot better thanks to that. There's a tool, especially for image classification, to be able to see the false and true positive, so all the good and bad results. And there's this quick tool called the confusion matrix, where you can see where it's doing well or bad. So here it's doing well for 4 different clouds and bad for the alto cumulus, where half of the time it is confused for something else. And what is the reason? There are 2 reasons. First, our data set is not balanced. We have less samples of the alto cumulus. And the other reason also is that the pictures for the alto cumulus, they are not diverse enough. There are many very similar pictures. So the result is that it doesn't work as well as it could. Okay. So the richness, AutoML is automating everything. But what you have to focus on is building a great data set, because the quality of your end model will be as good as your input data set. Okay. Once you have a good model that you've trained and you're happy with it, there are different ways to use it. You can launch batch predictions. So you just ask the API for predictions for results. Here, that would be for detections, for labels. And then you receive the results later. If you want to do live predictions, then you need to launch a deployment. So that's just one button. So here, what I've done is that I deployed one instance of my model. And then I have an API that I can call whenever I want. And here, in this case, means I can upload new pictures that the model has never seen. And the funny thing is that I think this is a picture from my smartphone, but I think I'm sure I took it in Poland. I think it was in Krakow 3 years ago. So my model has never seen this picture because the dataset was done before, or not at the same time, and didn't include this picture. And here it's able to detect that there's a cumulus in the picture. So that's good. So we've seen, again, on pictures, because that's very visual, but it works on text, videos, and even data. And some of the features that you've seen previously, like classification, you can do it your own custom way. So with AutoML Vision, you can do custom classification, custom object detection. With AutoML Video Intelligence, you can do custom classification, custom shot detection, object detection and tracking. So it means you can maybe detect objects in videos that the video intelligence is not able to detect. Okay, you can make these APIs more precise. Likewise, on text, you can do custom classification if the API doesn't work for you because you are very, very sharp, very precise, or need business needs, then you can do a custom entity extraction. You can detect specific entities related to your business, and also custom sentiment analysis, and even custom translations. I don't know if you have words, you have a vocabulary in your language that is very business. That's a business vocabulary that is not used by everyone. Maybe the generic API will not work. So you can customize the translation API. And something new also, and that will be of interest for the data scientist, is that AutoML works on data also, on pure data, tabular data. So if you have tables, so that's called AutoML tables. If you have tables, so that can be a CSV file, that can be a database, that can be BigQuery, so a big data tool. You can specify, so that what is the table? You have rows and you have columns. So you provide the rows and you specify your input columns and you specify your output. What is the prediction that you want to make? Can be on text, can be on binary, like yes, no, true, false, 0, 1, but can also be figures. You want to estimate numbers. And then it will build automatically a prediction model for you, okay? To have custom classification or custom metrics prediction. Okay, so I have done a live demo that's one that I have tried a lot. So I don't know how many of you are still following, but we'll try that all together. So in this demo, we'll try to detect generic emotions with the Vision API. But I'd like to know whether some of you are sleeping or not, having fun, or are tired because that's the end of the day. So do you have your tongue out? Do you yawn or do you sleep? Of course, nobody has done that in the world because there's no interest in doing that, no business interest. So I tried that with pictures. I just took a couple hundred of pictures to do that, and we are going to try it out, okay? So here's the architecture that I've used. There are buckets. From your smartphone, you're going to be able to send me a selfie. So the picture will be copied here from your smartphone. It will automatically trigger a cloud function where I will know the name of the picture in this bucket. I will call the Vision API to know whether there are faces in the picture. And then from my backend, so you will see that, I will administrate and will say, okay, let's do a generic detection or let's do an AutoML detection. You will receive the result back. I will do maybe some processing on the picture, some image processing, and then you'll receive the result here. And we'll see also the result on my laptop, okay? So let's try that out. I am, I know that there's something like 10 to 15 seconds of delay on the YouTube live stream. So I will give you some time to get connected, and so that we try to stay in sync. Okay, I will consider about 15 seconds. So I give you time here. You can either flash the QR code here, okay, or you can enter the URL bit.ly/mlsilesia20. bit.ly/mlsilesia20. I don't know how I should pronounce Silesia. I'm sorry. Or you can use the QR code. Okay, let me try. You should reach this page. Okay, and let me move to the step 1. If you refresh the page, it will ask you for the authorization to use your webcam, and you can try to trigger a generic emotion. So try to be happy, surprised, sad, or angry. So on my side, let's try to be surprised. Okay, so my selfie is uploaded in the cloud bucket. I know that there's a face. It means I can crop the face to forget everything around it. I know the location of the nose and the mouth, so I am mapping a mustache to every one of you. And the detection, the emotion here that is detected is surprise, and that's great. Let's try another one. So with the Vision API here, everyone will get a black mustache. Oh, so here a joy has been found. Okay, let's have a quick look whether it works with you. Okay, some of you, well, I will give you some more time. Okay, so I'm gonna do another one. Before switching, I will do another one. So of course, this model has not been trained with pictures of mine. So it does detect anger here. And let's try a last one, sadness. Sadness is very hard to mimic. So yeah, it's not sure. So of course you can decide on the threshold that you want to use, okay? So now let's switch to the AutoML part. If you refresh the page or go next, now this time it will call my own API, my private API, that is able to detect people with the tongue out, people yawning, or people sleeping, okay? So feel free. And this time the mustache will have the Polish flag colors. Okay, so here it does detect that I have the tongue out. Next, let's try to sleep. Oh, let's yawn. Okay, so it does detect with a high level that I am yawning. Okay, so if you want to improve the model, you can click that. So let's try. So, and there's a 15 seconds delay. So let's check what we have. Okay, so here, happy people with a mustache, surprised people, yeah, cool. Sad people, nobody. Hungry people, I was the only one. So now with the AutoML model, people with the tongue out, yes, it works. People yawning, it does work too. People sleeping, I didn't try sleeping, okay. And if you remember, the Vision API is able to detect objects. And so here, it means we have the people with glasses. Oh, did you arrive a bit later? Okay, maybe it wasn't sure that you were angry. Okay, but here, so we have more people. Oh no, so, yeah, so that's because of the delay. I'm sorry, the delay between YouTube and the demo. But when you try to be angry, I had already switched to the AutoML part. Okay, let's have a last look. If we have, no, it should be only in AutoML now. Yes, we have another participant with the tongue out. Nobody's sleeping? Okay, so you see? So I will leave the demo running for the evening if you want to play with it again. Okay, let's move on. So how does it work? So you see, it's very easy. You just need to do a data set. How does it work under the hood? There are three main techniques. One of them is known from the experts, so that is called transfer learning. So let's retake the example of the Vision API. We managed to customize it. So here on the left, you have the Vision API. It's actually a very, very big model with dozens or hundreds of layers. This model has learned on millions of pictures how to detect edges, how to detect textures, how to detect stuff at the macro level. So many different layers. But when we want to detect someone with the tongue out and we provide new pictures, then what AutoML does is that it builds new layers, additional layers here that are built based on the data. So this is why you don't need millions of samples, only hundreds or maybe 1,000. But it starts to work with a few dozens already. So that is at the core of the technology of AutoML. It's transfer learning, building new layers thanks to your customized samples. Something that is unique to Google, and there is a research paper about it, that we call that NAS, Neural Architecture Search. We also call that learning to learn or meta learning. So before launching the training, what happens, and that is very, very intensive in terms of computing power, we evaluate different architectures, different models, different ways to build the best model for you. One of them is the learning rate. Is it learning fast? It means the training will be faster and so on. And the quality also. How many layers should we have? What are the ends? So this is why we have built dedicated hardware. If you've heard of TPUs, tensor processing units, it's like GPUs, but it's dedicated to machine learning training and inference, so making predictions. Okay, so that's something unique to Google. And also another thing that we call hypertune internally is that we are able to automate the tuning of the hyperparameters. So during the training, experts, when they train a model, they are able to fine-tune some parameters that cannot be learned. And here we have an algorithm for that is called hypertune. And basically what it will do is it will be a better, it will find an optimum that maybe experts have not been able to find so far. What I learned recently is that actually it's now available in beta. If you actually are an expert and you want to benefit from this algorithm, so hypertune is actually available as Vizier in the AI platform. It's in beta, and you can use that to automatically optimize your hyperparameters. Okay, so these three techniques make it that AutoML works amazingly well, and you can get state-of-the-art models. This is the first time I present this new slide. It's a preview of my next project. So it's about object detection. And what I've done is that I've built a data set. I didn't need a lot of pictures. I just used about 100 pictures. But on every one of these pictures, maybe let me show as a close-up what I've done. So that is a PCB. It's a printed circuit board, an electronic board. And what I want to do is detect specific components on this board, the big ones that are called integrated circuits, ICs. And so what I've done is that I've used pictures of PCBs here. And for every picture in the data set, that's some work to do, but you need to give the bounding box for the components that you want to detect. You do that for all the components. You shouldn't miss any one, otherwise your model will be biased, but then you launch the training. What's cool on this specific use case is that my training ranged from 1.5 hours to 3 hours. One cool thing with AutoML is that the training stops as soon as you have a good model. So, I want always to get the best model. So I tend to specify 12 hours of training or even 24 hours. But in this use case, maybe it's an easy problem, I don't know. In this use case, the training, the AutoML training for object detection stopped after a couple of hours, between 1.5 and 3 hours on average. And I tried a lot of different stuff. So of course, I get a very, very good cloud model. But what I did and what was new for me is that I did an edge model to be able to export it. And the video I'm going to show you here, sorry, is actually a web page. Okay, so let me launch the video. So here I'm refreshing the web page. I am using a nice camera that you can see on the right that is doing a great autofocus. And as you can see, I can move my PCB in real time. I'm recording, so I am consuming some GPU and CPU power. But in real time, I can make 5 predictions in real time. And as you see, when the autofocus is good, it's able to detect automatically the components. That's magic. Honestly, that's a model that I could automatically train. I'm not an expert in machine learning. I don't know how to build a neural network, but I could generate my own custom model. I could export it. It runs in a web page. It's about 10 megabytes. So it means I could also embed it in a mobile app or whatever. And problems we had years ago on production lines actually would be solved today with this technology. So, so next step for me, if you follow me on Twitter, hopefully in a couple of weeks, I will publish an article with the source code on GitHub to show you how I did that, okay? Let's move on. So we've seen the APIs, we've seen AutoML, what you can do without any expertise. Of course, if you have time, if you're interested, you can develop expertise in machine learning. If I was in my 20s, that's what I would do 100% of the time. And for that, one of the standard now is TensorFlow. And we have, but that's not the subject tonight, it's just to mention it. And also PyTorch is another ecosystem that is very much used by experts. TensorFlow is the most popular open source machine learning repo on GitHub. And at Google Cloud, we have an AI platform that would be a topic that you can use as an expert, but also AutoML now. All the different AutoML features are available in the AI platform. It's a unified platform that you can use to do everything there and maybe develop some expertise. So time to wrap up. What have we seen? How can you build smarter solutions? So with the email APIs, you just need hours. So the demo that you've seen at the beginning, especially for face detection, it took me a couple of hours. In one afternoon, for the first time, I discovered how to detect faces, and then I could do face detection in 2 hours. With Code Labs, now you can do that in a few minutes, and it works right away. For AutoML, I needed, and the demo that you saw with the tongue out and everything, I needed 2 days. I did it in 4 passes, so about 4 half days. And the first time it worked okay. My data set was too small and everything. I collected more samples. At conferences, some participants helped me by saying, okay, I'm okay to give you my selfies to improve your model, and my teammates also. So it took me 2 days. And then also the model took a few hours to train only. If you want to develop expertise, you need to invest more time, weeks, maybe months, and maybe a few years of your life also, if you want to be a specialist and a real expert. You could spend your whole life to digging this field. What's the difficulty for the machine learning APIs? No difficulty at all. You just need a couple of hours to use it. And you can focus on using the results and making a good use and benefiting from the results, making something smart out of it. For AutoML, the only difficulty is the data set. You need to build a balance without any bias. So balance means it needs to be balanced but also diverse. You need to provide real life and diverse examples. And if you want to become an expert, the difficulty can be very difficult, because maybe you will focus on innovation and you need to do everything by yourself. But once again, cloud technologies, and that's why I'm focusing on cloud technologies for 4 years and for a lot longer now. In the future, cloud technologies can make everything easier for you. You can deal with petabytes of data thanks to BigQuery. You can have terabytes of files in the cloud, and you can do everything from your laptop, and you don't have to build very expensive hardware anymore. Okay, here are a few pointers about the different APIs, about AutoML, the AI platform also. Here are additional pointers of what I've written. So those are the machine learning API code labs that I wrote or that I maintain. And those are some examples. So it's a first series of 3 machine learning articles. It's on Medium. If you check out on my Twitter, you will find that. Here on the first article, I showed how you can build in less than 300 lines of code, how you can build a video processing pipeline. You just take a video, you copy it in a bucket in the cloud, and it triggers, like the demo you saw before with the face detection, it triggers the video intelligence API and builds up automatically an animation here. It's a visual summary of your video. So maybe your video is 10 minutes long. You don't want to watch 10 minutes of your video. But here in 10 seconds, you can have a very, very good idea, a visual summary of your video. Likewise, the second article is about generating animations of the different objects that are tracked in your video. So that's another way to have a good sense of what has been found in your video. My latest article is about face detection. If you want to reproduce the demo that you've seen, it's less than 300 lines of code. There's a web front end, of course, in JavaScript, but here it is making a call to the Vision API, and you can try that with your webcam. And also I focus on serverless. That is another very, very cool, true revolution as a cloud technology. Okay, here this is also a pointer if you want to maybe refresh your memory about all the different machine learning vocab, the different terms, and maybe learn more that or get a better refresh than what you've seen tonight, especially maybe on data and regressions and everything that I didn't cover tonight. So it's a very nice machine learning, a very nice comic about machine learning done by Google AI. Okay. So here you can find the slides. They are online. And here you can send me feedback if you like now or a bit later or in a few months. You can come back to me. The presentation should stay online. Okay. So that was it for me today. I hope you learn a few things. I tried to cover as much as possible in a not too long time. I hope for you it was not. I hope it was helpful, and ideally, I hope it gave you a few ideas. So feel free to come back to me if I can help or if you've done something cool. And now is the time for questions. Maybe if you have questions.
Yeah, thank you, Laurent. Yeah, let's start with questions. It was really insightful. Yeah, the first question is it true that Google Cloud's serverless functions will accept Dart programming language in the near future?
I don't know. But so is the question. So the question is, will we support Dart in a serverless product, right?
Yes.
Actually, so I'm not aware of any insights. Maybe we have communicated about it, but what I can tell you is that you can actually already do it because if you know Cloud Run, so Cloud Run is a serverless. So that's the latest revolution, is a serverless product working with containers. And a container is the generic way to embed anything and get it to run in the cloud. And so it means you can do your Dart application. If you know how to deal with Docker files, you can make a Docker container with your Flutter, your Dart application. Maybe we have something in the pipe, I don't know, but you can already do it with Cloud Run. And if people are working on it, then you will have even more and more resources. So that's not machine learning, but on the serverless part, there's something cool and new that is called build packs. And so with build packs, you can actually point build packs to your source code, whatever that is. So everything I've mentioned with the client libraries, Java, Python, and so on are covered. You can build actually automatically a Docker container without knowing nothing about Docker. So that's the start. It already works great. But maybe what you've heard is that, and I don't know, is that Dart will be also covered by by build packs, maybe. So maybe you will automatically build a Dart container. I don't know. I hope it answers your question.
Yeah. Okay. So the next question is: are those apps available for everyone to play with, or only paid plans for Google Cloud Platform?
I'm not sure. Can you repeat the beginning of the question?
Right. So are those apps that you showed us with the machine learning on the basically the learning part of the models? Are those for free, or we have to pay for it to use the cloud?
You mean the APIs or AutoML or both?
Yes.
Yeah. Okay. So the APIs, you only pay for what you use. So for instance, I don't know about the prices or not well, but there's very often a free tier on Google Cloud. So for instance, with the Vision API, I know that you can do predictions on a first set of 1,000 pictures for free every month. And then you pay for the next set of 1,000 pictures and so on. On AutoML, that is different. So on AutoML, you pay for the training. So when you launch a training, you specify a budget. You say, okay, my edge model, I want to launch a training of 3 compute hours. And then if it uses the whole budget, 3 hours, then you will pay for 3 compute hours. And if it stops before because the model has converged, then you will only pay for the time, the training time. Then if it's an edge model and you export it, then you can use it wherever you want. And virtually in a web page, it can be free. If it's a cloud model, if you do batch predictions, then you pay for the time the API is on to make the batch predictions. If you want live predictions, and then you deploy instances just with a button, but you say I want 1, 2, 3 or more instances of your custom AutoML API, then in this case you pay for the machines as long as they are live. So it's up to you. You can decide. You pay for the training for sure because that's at the heart of AutoML, but then you can only pay when you use it, or you can even also export it. To give you an idea, if I go back to this, I've done 2 models for this, and the cloud model I did, I paid 35 euros for a couple of, so it finished in 3 hours, I think, but it was more hours because cloud trainings are distributed over 9 different nodes. So it goes faster than your budget. But so I paid 35 euros, I think, for the edge model. So to train an edge model, it's a bit more expensive. But then you don't have to pay to serve the API, right? Because you can use it wherever you want. For the edge model, so this one that works in a web page, but could work on the Raspberry Pi, it could work on my mobile phone and so on, I paid around 60 euros, so almost double. But the training time was different also. So it's up to you. You decide how much budget you want to put. Of course, very often you want a high quality, but in this, maybe it's an easy problem. I don't know. In this use case, it's nothing. 30 to 60 euros for a state-of-the-art model like this. Maybe you would need a real team of machine learning experts to do that. And it would take maybe months to do it. Here, in a matter of days, you have a solution. And you can also, in a matter of hours, you can build a POC. You can say, okay, let's see whether that is viable. Would that be a solution that would work? And you don't need a lot of money to try it. Actually, it doesn't need a lot of money and not a lot of time.
Yeah, thank you. So another question, I think you mentioned that about the video, but somebody is asking, is the sound also processed by the video analysis tool?
As of today, there's no AutoML speech, if that's what you are asking. If the question is about the video intelligence API, so yes, when you provide a video, you can get insights from the frames, but also you can ask, without doing it by yourself, you can ask for speech to text transcription from your video. What you don't have today is AutoML speech. Okay, I hope it answers your questions too.
Yeah, I think so. Okay. Another question is, I'm pleased with Machine Learning Kit mobile results. Unfortunately, that works only on devices with Google services. Will it be enabled in the future for the other devices too?
So if you talk about AutoML on mobile, it does work on iOS. So you can actually do maybe not all the AutoML's models. What I showed is all the possibilities, but for some specific. So for instance, for the custom natural AutoML natural language, maybe you cannot do it on iOS yet because there's no demand. But I'm sure that for pictures, you can do custom classification or custom object detection. Yeah, that is and so I'm reading the question. Sorry, I'm pleased with machine learning, the machine learning kit mobile results. Okay, that works only on devices with Google services. So to my knowledge, it does work. You can and I think it's called ML Kit. You can get it to work on iOS, and it doesn't work. It doesn't have Google services on it.
Mm-hmm.
So yeah,
I think somebody is asking like Huawei because they are.
Okay. So on an Android device, maybe it's okay. I get it.
Okay. Yeah.
It's on the mainstream devices. Maybe there's a dependency. So I'm not. I don't know about it. If there's a dependency on some on Google Play or whatever, I don't think so. Maybe it must be a different dependency.
Mm-hmm.
So I'm sorry, I can't answer these questions properly.
That's fine. So can you please recommend us some books or tutorials that can help the beginner in the AI and machine learning for those applications that you just discussed?
Yes, so that are check out my slides, so that are online. Those are really here to try with code, to try that. So that's with Python, but you will find that with some other languages. There are 6 different code labs to try the APIs. So try that. If you want to invest into TensorFlow, which I have not done, you will find plenty. It's a real, it's a big ecosystem now. So you will find plenty of tutorials, plenty of code labs. If you're into Python, there's something cool that is called notebooks. So you will find plenty of notebooks. So that is actually code that you just can copy paste or just that is shared with you. And then you can execute the different lines and reproduce everything. There's a great platform called Colab, Google Colab. So not Codelab, sorry, Colab, C-O-L-A-B. It's like a Google Drive for notebooks. And there you will find notebooks that are shared from experts that you can just copy and execute. And what's cool on Colab is that you can actually try, so with some limitations, but you can try to do, if you invest time and develop expertise with TensorFlow, you can actually launch trainings with GPUs and even TPUs. I think that the limitation is 1 or 2 hours of training time with TPUs, but you can actually try that out. Okay, of course, it's really it's an educational platform, but other than that, you can use the AI platform, and then you can do everything without expertise with AutoML or with expertise by using tools that experts are using there. All right, like fine tuning, diving into the data set, using specific algorithms, maybe watching the neural networks, how they are built and everything. Okay.
Yeah, I think I even used the Collabs before. It was really easy to use for a beginner, so I also recommend. Another person is asking about the stock market, basically, if we can use AI to predict the stocks and then use that model to generate some income. And if you could give us some real-life examples of it.
So on the AI platform, there are new features in beta that I didn't mention. There's one that is called it's not called time series, but if you look for AI platform and time series, so it's AutoML. It's actually like it's AutoML tables. So you have rows and columns, but one of your columns is a daytime. It's a day and a time in the day, and so you have different rows that are logically linked. And AutoML tables will be able to build predictions that are based on time series. And I'm not telling you that you will be able to do stock forecast and earn a lot of money. Otherwise, everybody would be doing that, and the stock market wouldn't work. It can work on some specific use cases, but the stock market is, maybe there are models. I'm pretty sure experts have done models, and maybe you could do an AutoML model out of that. But what I have tried with AutoML tables, and I was surprised, is I tried a Kaggle contest. So Kaggle is an expert community where there are contests. So companies want to solve a problem. They provide a data set. They provide a price. Some of the prices were $1 million. And experts were for weeks and sometimes more, and try to give the best prediction. And they build the model by themselves. And so what I've tried is, for instance, one of the data set is what is the price of a house, depending on many different factors, are the number of rooms, the how big is the house, where is it located. So it's a big data set with rows and columns. So I just took the data set, I input it into AutoML tables, and I said, okay, what I want to predict is the price of the house. That is my target column. And I said, okay, use all the other columns as a potential input. I launched, I think it was, I said, okay, I want to launch a 12-hour training, and it stopped after maybe 6 or 7 hours. But it was magical because AutoML is just amazing. Tables, also in this case, with just a few hours of training and without any expertise, and experts work for weeks on this problem, I was in the top 6%. So of course it was like a cheating. And I did say the contest was over, but I tried after the fact, and I was in the top 6%. I could also watch internal videos of experts from the AutoML team doing something similar. So it was a harder problem. It was a data set given by a bank or a company working for banks. And banks, they try to detect fraud, especially fraud with bank cards. And so it was a big data set with cards that had been detected as fraudulent. So card transactions. So many different transactions. And what happened when the contest started for real? The AutoML team tried on their side to make an automated training of a few hours, of 12 hours and 24 hours. And they got very, very good results. And it took worldwide experts 2 weeks to reach the same level of quality with the models that they had fine-tuned by themselves. And it's a real community. So, I mean, they exchange information to make the models better and better over time. So with AutoML, if you have data and you want to make predictions, once again, you need to be careful. For instance, you have to be careful about not giving about that data leakage. Maybe I will give you another example. But if there's data leakage, and there was in this case on the bank card fraud, there was some data leakage in the data set, so AutoML tables didn't work that well. But it took 2 weeks for the experts to catch up with the results from AutoML tables. Let me give you another example about data leakage that I could witness on scans of lungs, so in the medical field. And this is maybe something that you will find out if you try AutoML Vision. So on this specific use case, experts wanted to find cancer in lungs. And for that, they used actual lung scans. And with the first model, they got very, very good results, like 95% of lung cancers were actually detected on these scans. So that was amazing. But actually, what happened is that the machine learning model learned to detect pencil tracks, because when experts, let me show you, when experts when doctors analyze scans, they do that like that. They put the scans on the board and they say, okay, you see here, there's a cancer. And what happens, that is that data leakage. If you provide this, what actually happened is that the machine learning model learned to recognize the pen marks on the scans, not the actual cancer, but the pen marks. Or likewise, if at the bottom you say that is one with cancer, that is one without cancer, and it's written, or there's a color, it's green without cancer and red without cancer, the machine learning model will go to the fastest path to learn that. And it will say, okay, there's green, it's without cancer, it's red, there's cancer. So that is data leakage. So you have to be careful in your data set not to provide an easy solution. Okay, and that was funny in this case with radiography, that the machine learning model learned something different. So be careful about that. Yeah.
Yeah, thank you. And the last question that somebody asked is, if I would like to work for Google in machine learning field, do I need to learn math behind it or use the APIs? Also, using APIs is enough for it.
If you want to work at Google, you mean?
Yes, in the machine learning field.
No, if you want to, if you want to develop machine learning models at Google, Google is working on innovation, right? So that is very, very sharp, and you need to invest time into working in machine learning. So in deep learning, you need to become an expert. So it's called Google Brain or Google AI. So the Google Brain team at Google, there are research centers in many, many different cities around the world. I know I don't know in Poland, but I know there's one in London. We opened one in Paris a couple of years ago also. And people working there, they are really experts. Very often they have PhDs. So yeah, if you want to work in the Google Brain team, most likely you need to become an expert. But if you want to work at Google Cloud and develop cool technologies, then you need to be a good software engineer and maybe not a machine learning expert. And for instance, the AutoML platform is using Google Brain technology. but is developed by software engineers who are not experts in machine learning. So yeah, I hope it gives you some perspective.
Yes, there's no easy way there. Yeah, that was the last question. So thank you for sharing your knowledge with us. And yeah, if you guys want to follow around on the Twitter, then there's a link and all the slides. We will add the links later. Yeah, and I hope you enjoy it. Write in the comments if you enjoy it. Give him some feedback so he can improve in the next sessions. And thank you for today.
Thank you, everyone. Take care. Bye-bye.